All right, my second hour, class of 2025. Today's lesson we are doing, you should all have this note sheet in front of you that says exponents at the top. We are starting section 2.9, and you're going to follow along notes with me as you watch this video. It is talking about exponents, as you can see. Now, I know you know some things about exponents already. I'm going to jump over to this section right here. We're going to be doing a lot with exponents this week. Probably quiz on Friday it's setting up for right now. And we're going to do a lot with exponents, positive exponents. We'll talk about something when we deal with negative exponents that you probably haven't seen as much in the past. And then how to simplify a bunch of different expressions that have exponents in them. But let's start over here first, positive exponents. First thing to note, a couple vocab words that we need to know. First of all, whenever you have something that has an exponent on it, this whole expression right here has a name itself. It's called a power. And again, as you see me circle things and write down vocab words, you should be doing the same thing here. So this whole thing, since it has an exponent on it, and I'll write it out in words in a little bit, but what that expression is, but that is called a power. Then each of the numbers in a power has a name as well. The small number we know is called an exponent. So the 7 in this case is called an exponent. And the big number, actually, the number that gets multiplied again and again, actually has a name too. That's called the base number. I know some of the problems in the homework will be asking you these vocab words, so you do need to know them. Yes, you do. Okay. So a power is combined with a couple numbers, the base and the exponent. Okay. What this actually means, is, I know many of you do, this one in particular, I would read this off as 2 to the 7th power or you could also say 2 to the power of 7. There's how I would say that expression in words, that power in words. What it really means to do, and maybe you could tell me this or have seen it in the past, but it means to take the base number, in this case 2, and multiply it by itself as many times as the exponent tells you to. So in this case, it'd be 2 times itself 7 different times. 2 times 2 times 2 times 2 times 2 times 2 times 2 again. Now sometimes we'll write things out like this to help us multiply, and then sometimes if it says evaluate, we'll actually just figure out what the actual answer is. And in this case, 2 to the 7th power, I believe, is 128. We can double check that, but that's us actually evaluating that power and finding out what 2 to the 7th power is. You should try these examples down here, and I'm going to fill in the answers in just a second. Okay, hopefully you took a second to try these problems at the bottom here. That first one, I know it's kind of hard to tell from the way it's printed, but it does say 3 to the 4th power. That is a power. The base number is 3. The exponent's 4. And so that means to take 3 times 3 times 3 times 3. 3 times itself 4 different times. And again, you don't have to know the answers off the top of your head. You can just kind of even go 2 at a time and say, well, 3 times 3 is 9. And if I do it times 3 again, that'd be 27. And do it times that last 3, that'd be 81 is what the answer for that one should be. Even if you have fractions, as you can see in example 2 there, doesn't matter. Still the same idea. And we just finished up multiplying fractions, so we know how to do this very well. Even a fraction squared, as it says 1/2 squared there, and that just means 1/2 times 1/2, which is we know to multiply just across the top and across the bottom. So 1/2 times 1/2 gives me 1/4 for that one. And now I'm definitely going to write out this last one, -8 to the 3rd power. Well, again, I bet many of you could write out what that means. That means -8 times -8. I'm going to use parentheses in this case because I have the negatives, just to make sure it's highlighted that each one is -8. -8 times -8 times -8. Well, we know our rules for this as well. When I multiply a negative times a negative, right, it's going to make a positive. So when I multiply those first two, I'm actually going to get positive 64. But then I still have to multiply it by another -8. And when I do that, it's going to change the answer back to a negative again. And even I'm going to have to pull this one off to the side here for a second and multiply. If I do 8 times 64, I'm getting 512. And it's going to be negative because, again, I multiplied by that third negative. So negative 512. When you are dealing with negative numbers that are the base, the answer could be positive or negative depending on the exponent. We'll learn more about that as we keep continuing this section. Now, next thing I want you to do actually is to flip your paper over. I'm going to teach you about what it says up here in terms of negative exponents, but I want you to flip your paper over. I'm going to show you an example I think that will help you understand it better. All right, so on the back of your page here, I want you to write down what I've got at the top here. And again, I think this will help with the next part. We're going to talk about negative exponents, which are different from something you have not seen and probably didn't even know that can happen. You can have an exponent that is negative. But I'm going to use the example here that I have and these powers of 2 to show you maybe the pattern to help you understand how it does work out. So you should write down what I got at the top there in terms of words, and then all of these here as well. And again, I'm going to show you how that leads up to negative exponents. I know none of these are negative, but just kind of recapping what we have up here, right? 2 to the 5th power, as this one says. It says it equals 32, and I'll just remind you, though, that means 2 times 2 times 2 times 2 times 2, right? 2 to the 5th. 2 times itself 5 times, which is 32, okay? And then we have 2 to the 4th, which ends up being 16. 2 times itself 4 different times. And then 2 to the 3rd, which is 8. And then 2 squared, which is 4. And 2 to the 1st power, which is 2. Okay. Well, in math, we're always looking for patterns, you guys. So notice that as I go down by 1 every time with the exponent in my powers, what's happening over here to the numbers? You should think to yourself, what is happening right now? I bet you could pick it out. It goes from 32 down to 16, and then down to 8, and then down to 4. Well, as you take a look carefully, I bet you could figure out that it looks like it is, oops, and I wrote it wrong, but it's dividing by 2 every time as we decrease on the right side there. Every time I drop the power by 1, it divides these numbers by 2. So 16 divided by 2 gives me 8. 8 divided by 2 gives me 4. 4 divided by 2 gives me 2. So notice that the pattern keeps going here down to the last one. And we actually have 2 to the 0 power. And maybe you didn't even know that that can happen too. But I can have something to the 0 power. And crazy enough, it's not 0. And also crazy enough, it's not 2, because here's the case where 2 to the 1st power is 2. But if I keep following the pattern that we've seen on the right side so far, anything to the 0 power, and this works for any number, you guys, crazy enough, keep the pattern going. It's dividing by 2, dividing by 2, and so you got to take 2 and divide it by 2. It ends up being 1. Anything, because here's a little note to make before we even get to negative exponents. Anything to the 0 power is 1. Now that seems pretty crazy. 7 to the 0 power, 1. 64 to the 0 power is 1. Even a variable, x to the 0 power, because it just stands for a number, so some number, whatever it is, to the 0 power is still 1. Even if I have even kind of a trick question, what if it's a negative number? Negative number to the 0 power is still even just positive 1. So something to note, we'll use that a bunch going forward. Anything to the 0 power ends up being 1, doesn't matter what the base number is. Okay, now getting into the negative exponent part like I promised. So notice that we did all those 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0, and now we're finally down. If we keep this going, I'm going to have 2 to the negative 1st to be the next thing I would write. And then I'm going to do a couple of them, 2 to the negative 2nd, and then 2 to the negative 3rd. You are writing these as well along with me. And I bet you'll be able to figure them out once I show you the pattern, 2 to the negative 4th. Okay, so write those below. Keep our little list going here. Okay. Now, remember what we talked about above. As we kept decreasing the power by 1, we saw a pattern on the other side. And I'll tell you, Seems kind of crazy, but that pattern continues. It is still the same thing we've been doing. Since I'm decreasing the power by 1, right, going from 0 to negative 1, I'm going to divide by 2 on the other side. It's amazing, but a negative exponent does not make a number negative. What it does, and you'll start to see the pattern is, but if I keep this divided by 2, what I'm going to get here is 1 over 2, 1/2. 2 to the negative first power is 1/2. Not negative, just 1/2. Let me do it again. I'll tell you what the next one is. If I keep that pattern going, and again, if I took 1/2 and divided by 2, I'll do the math for you. I'm going to tell you you're going to get 1/4. Okay? Now hold on to it before you start to make the connection. I'll do the next one for you. 2 to the negative third is actually 1/8. Now, I'd like you to try to figure out the last one yourself. Take a look. 2 to the negative fourth. Look at what we've done so far. If I was going to have you look at one more thing to maybe help make the connection. Look what happened with 2 to the first power and then 2 to the negative first power. Okay? See if you can see a pattern here. 2 to the second power, 2 to the negative second power. This one is 4. This one is 1/4. Look at the next one. I'm going to use green here for this one. 2 to the third is 8. 2 to the negative third is 1 over 8. So maybe now you can start to see the pattern. What happens with a negative exponent? Well, we've talked about this word in the past. It kind of like takes the reciprocal of what the number would be if it was to that power. So 2 to the fourth, just kind of side note, as we know from above, is 16. Well, 2 to the negative fourth is 1 over 16. Okay. Again, this takes a little bit to think about, and you will get better as we work with it. Okay, let's flip over to the other side and look at some of the problems that they have on that side now dealing with negative exponents. All right, so back to this side. If there's one note I want you to make about negative exponents, now I'm looking at the middle section here. You need to write this down. Negative exponents, most importantly. I said it on the other side, but they do not make the answer negative. As funny as that sounds. Instead, it is more like they take the reciprocal of what that power would be. That's one way we can think about it. There's some other ways too you learn as you start working with these more and go into 8th grade, but it takes the reciprocal of that power. That is one way we can think about it. Okay? That may help us with these problems. So we kind of had this one on the other side, but 2 to the negative third power, which you're going to find out, one way you can write it is really just 2 over the third. Again, it kind of puts it in the denominator because it takes the reciprocal, or which ends up being 2 to the third is 8, 1 over 8. Okay, again, you can think to yourself also the other way, like we said, reciprocal. 2 to the third is 8, so 2 to the negative third is 1 over 8. Okay, take a look at that next one. Negative 6 to the negative fourth power. Well, if it helps you for a second, just think about what negative 6 to the fourth power would be. Okay, and I'm going to write this one out just to help. Negative 6 times negative 6 times negative 6 times negative 6. Okay, if I was multiplying negative 6 times itself 4 different times, I'm going to shortcut just a little bit here and say, well, these two together would be positive 36. And I can do these two as well and say this would be positive 36. And now I could do positive 36 times positive 36, which would be, I'll have to do some multiplication myself. 216, bring down a 0, 18, bring up the 1. 6, 9, 2, 1, 1296. But now taking that back up to here, what a negative exponent means, again, it's kind of like the reciprocal, so it's kind of like 1 over 1296. Okay? Negative exponent takes the reciprocal of that number. Is the kind of one way we can think about it for now for 7th grade and what we're dealing with. Okay, so let's finish up with a few other problems like you might see on your assignments going forward. So again, the fraction ones, don't be too intimidated by the fraction ones. 2 to the third squared. That just means, and I think these especially help to write out, 2 to the third times 2 to the third. And we know that we can multiply across the tops and bottoms of the fractions, and I can get 4 over 9 for that one. So not too bad in that case when I'm simplifying an expression that has a bunch of these things to deal with, okay? All right, this next one. Now, we've got a couple different powers multiplied together. Well, that first one's 3 to the negative second. Well, let's just deal with this one separately first. Well, we know that 3 to the second, as we talked about, is 9, right? So 3 to the negative second, we know. I'm going to write it over here now. I'm just going to bring it over here for the problem, is 1 over 9, okay? Times, well then, let me do the next part here. So next part is 2 squared. Well, that 2 times 2, that's not a negative exponent or anything, right? That's just 2 times 2, which is 4. And then the last part, we learned on the other side, anything to the 0 power is 1, right? So this would be just crazy enough. 4 to the 0 power is just 1. All right. Now we got to multiply all these together and realize, again, if something's not a fraction, I can make it a fraction. 4, I can just put over 1. And times anything by 1 isn't going to hurt it. So that last 1, I'm just going to erase that because I'm not going to need it. When I times anything by 1, it just becomes that number. So here's me erasing that, okay? And we know to multiply fractions across the tops and bottoms. So 4 times 1 gives me 4, and 9 times 1 gives me 9. So 4/9. There's us simplifying an expression that's got a lot of powers in. Nothing that we can't handle. Okay, now let's do that last one. 6 squared, starting off with that. And again, we know PEMDAS, right, tells us exponent should be first anyway. So 6 squared is 36. Minus 3 squared, which is 9, plus, now 1 to the negative first. You know, if I had 1 to the first, that would just be 1. And then if I take the reciprocal of 1, well, what do you know? 1 reciprocal of 1 is still just 1. So this one, I'm just going to have 1 at the end of this one. 36 minus 9 gives me 27, plus 1 gives me 28. So we can simplify expressions that have powers as well. Okay, you're going to try your assignment today. Good luck. If you need help, don't worry. Help each other. Ask Miss Morris. If Mr. Kutchell can help you, ask Mr. Kutchell. And otherwise, again, I will be back tomorrow too. But do the best you can.